Hi, this video will be looking at forces and motion. The acceleration of an object is determined by two factors. The first factor is the resultant force acting on an object, which was explored in the section before, and the second factor is the mass of the object in question. We can work out the acceleration of an object by using the formula below. The formula is A equals F divided by m, where A is the acceleration of the object in meters per second squared, which is m divided by s squared. F is the resultant force in newtons, and m is the mass of the object in kilograms. The formula triangle for acceleration looks like this. We have F at the top, and then we have m and a at the bottom. So let's have an example. Suppose that a car has a mass of 1500 kilograms and the engine provides a driving force of 4,500 newtons. When the car is driving at 50 miles an hour, the car experiences air resistance and drag of 4,350 newtons. Work out the acceleration of the car when it is travelling at 50 miles per hour. The first step to answering this question is to work out the resultant force, and if you're feeling confident in working out the resultant force, pause the video now and have a go. It is easier to work out the resultant force by using a diagram. So here we have our car, and we're going to assume that it's travelling in a rightwards direction. Our car is currently travelling at 50 miles per hour. The driving force of this car is 4,500 newtons. At a speed of 50 miles per hour, the car experiences air resistance and drag of 4,350 newtons, and this is acting in the opposite direction to the direction that the car is travelling in, i.e. there's 4,350 newtons acting in a leftwards direction. We work out the resultant force by summing all of the forces that are acting on this object in one direction. Let's work out the resultant force to the right. This means that the driving force is positive, so we have positive 4,500 newtons. Drag and air resistance is going to be negative, and this is because it is acting in a leftwards direction, which is opposite to right, and right is the way that we're calculating our resultant force for. This means that we'll have minus 4,350 newtons. So the resultant force is 4,500 newtons plus minus 4,350 newtons, and this gives us a resultant force of 150 newtons in a rightwards direction. As the resultant force is in the same direction of the direction that this car is travelling in, it means that the car is going to accelerate. So the answer for acceleration needs to be positive. As we now have the resultant force of 150 newtons, we can now work out the acceleration. The formula is A equals F over m. The resultant force is 150 newtons and the mass of the car is 1,500 kilograms. This gives us an answer of acceleration of 0.1 meters per second squared. We can extend the example and work out the acceleration when the car is stationary. When the car is stationary, there will be no drag and air resistance on the car. This means that the resultant force will be 4,500 newtons in the direction of travel. We can use the formula above again to work out the car's acceleration. So it will be the resultant force, which is 4,500 newtons, divided by the car's mass, which is 1,500 kilograms. This gives us a value of acceleration of 3 meters per second squared. It could also be the case that we are given the acceleration rate and the resultant force, and we are asked to find out what the mass of the object is. So let's have an example of that. Suppose that we have an object that has a resultant force of 1,000 newtons and the acceleration rate of 2 meters per second squared. What is the mass of the object? We can use the formula triangle to find out what formula we should use to work out the mass of the object. We do this by covering up the mass and completing what is left in the triangle. The formula that we need to use is mass equals resultant force divided by acceleration rate. So in the question we are told the resultant force is 1,000 newtons and the acceleration rate is 2 meters per second squared. So we do 1,000 divided by 2, and this gives us a value of 500. Therefore, the mass of this object is 500 kilograms. This brings us to the end of this video. For more content, quizzes and past papers, go on to www.elevise.co.uk.